Okay, so on the last one, or our last two examples rather, we showed that we could combine them and make a system. And so I wanted to throw one last example in here where we can think about an external force that's opposing the motion and see how we can deal with that. We're going to start with the same thing. I'm going to go mass 1 and mass 2. And I'm going to start with my free body diagram. That's key and required on every exam problem. So for mass 1, here we go, make sure I do the right one. I have the force of gravity down. I have the force of tension up. So far that seems pretty nice. There's only those two. This one, I kind of drew a little line in between because we're talking about that second, this comes up off the ground. Notice this weighs more, or it has more mass than this one. So this one is going to accelerate the system this way. So you are much better off to think of this in terms of just having lost contact, that this problem is going to look at that split second when that normal goes to 0. So for mass 2, let's see, what do I have? I have the force of tension up and the force of gravity down. So on the surface, this looks like exactly the same free body diagram. I need to remind myself that these two force of gravities, they're different because they have different masses. The force of tensions are the same, but what about the direction of acceleration? So if I look at this, oh, I don't want that color. Let's go with this color. If I look at this, this is the more massive one, so I'm going to get acceleration coming down that way. And on this one, I have acceleration, well, it's going to be going up. So its acceleration is going up. Ooh, so that means that I'm going to have accelerations in two different directions, even though they have the same magnitude. So I have to be really careful there. So let's define for myself, it really only matters if I'm going to go up or down as far as positive, but to be consistent, I'll do that. So I'm going to define down as positive just because I chose to. No other reason. You will get the same answer no matter how you define it. So for both of them, I get, let's see, force of tension, force of gravity, sorry, minus, so this is a sum in the y. I'm careful with my habits. So force of gravity down is positive force of gravity minus the force of tension. That equals mass 1 times, this is going up, negative acceleration. That's where you get messed up. This one here, though, I have force of tension up is negative. So once again, I have the force of gravity minus the force of tension. Oh, shoot. I did. Darn it. Okay. I'm not going to start this over and do this whole thing from scratch because that's annoying. All right, let's see the mistake I just caught myself doing. This is mass 2 because it's going up. So all I'm going to do, please don't panic, is change that to a 2 and change that to a 1. Because I did this based on that mass, not on that mass. All right, that's why it's important. So force of gravity down is still positive, that part's correct. Force of tension is up, so that's negative, equals, let's see, I'll do it in the same color, sorry about that, equals, let's see, this mass times its acceleration. Well, this mass here is accelerating in the downward direction. I've defined that as positive. So mass 1 times acceleration. Let's clean this up. So I have this force of gravity. This is for mass 2. So mass 2 times gravity minus the force of tension equals, there we go, equals mass 2 times negative acceleration. I'm going to write that again. M2G minus FT equals negative M2A. This is not saying the mass is negative, it's just saying that the acceleration is negative. And then this one, M1G minus the force of tension equals M1A. So let's see, we don't know acceleration, we don't know tension. But what I can do is solve for one of these tensions. So I'll go ahead and do this one because this one looks uglier. I'm going to move the mass to acceleration over here by adding it, and I'm going to add the force of tension to that side. So I'll have mass 2 times gravity plus mass 2 times acceleration equals the force of tension. So now this looks a bit uglier, but now I can do this substitution. I've defined what the force of tension is right here. So I'm going to substitute these values into here. Let's see what that looks like. I have mass 1 times gravity minus mass 2 times gravity plus mass 2 times acceleration. So that piece equals mass 1 times acceleration. Let's distribute that negative sign. Mass 1 times gravity minus mass 2 times gravity minus mass 2 times acceleration equals mass 1 acceleration. Now we want acceleration. So my habit is to take the thing that I want to solve for. I know the masses and I know the acceleration due to gravity. Let's remind ourselves of that. Remind ourselves that G is 9.8 meters per second squared. So that's known values. The acceleration is the thing I don't know. So I'm going to move that to this side. I like to do it that way because it also keeps everything positive in my answer on that side. So I have mass 1 gravity minus mass 2 times gravity equals mass 2 acceleration plus mass 1 acceleration. Same trick, I'm going to factor that out. So mass 1 times gravity minus mass 2 times gravity divided by mass 1 plus mass 2, equals A. So let's think about this. Remember on the previous problem, I said, okay, we can treat this as a system. This was the force causing the acceleration. These were the masses being accelerated. This mass 1 gravity, oh yeah, that's the force causing the acceleration. What's opposing it? The only external force, which is the force of gravity also acting on this mass 2. So the way you can simplify this problem is to do the combined masses, if I wanted to. Let me do it over here. This is my combined masses. This is 50 kilograms. Yeah. Let's see. So it has the force of gravity down and a force of gravity opposing. So what force of gravity is making this acceleration? Well, that is that mass 1. So force of gravity 1. Which one is opposing it? Force of gravity 2. So I can rewrite that. That my force of gravity, so my sum in my y's, if I had to go down as positive, becomes force of gravity 1 minus the force of gravity 2 equals mass 1 plus mass 2 times acceleration. Isn't that the same darn thing we just did all this work for? Pretty cool. So there are two different ways that you can go about it. For a lot of people, combining them and doing this, combining them like this makes a lot more sense and they're able to see it. The biggest caution I would make for you is make sure that you really keep straight what force is causing the acceleration and what force is resisting it, and make for darn sure that the force that you think is resisting it isn't an internal force. So remember this one, this force of tension, that was an internal force. That's not resisting the overall acceleration. If I had friction here, that would be an external force that's resisting the acceleration. This one, the external force resisting the acceleration was the force of gravity acting on that mass. the thing making it go, the force of gravity on that mass. So you can do these. I do not require you to do it one way or the other. You can do it either. But what I do want to say for those of you that are like, why would I do all of this, is there are steps along the way that being able to do these substitutions is going to be incredibly important. And it's going to save you a lot of time. I'm actually going to require it because I'll have a couple questions that are no numerical values. So you have to have these math skills. So make sure you're comfortable with that. If you're comfortable with that, then by all means, you can jump right to that. Let's go on an elevator, shall we?